Hey there, welcome back. Hayes' World of Math. We're talking inequalities. Lots of facets to inequalities. We're going to go through a bunch of different examples for you, and hopefully this will help you get to understand how to go through and solve it, or at least how we do it here. Obviously, like, subscribe, comment when you have a chance. Down below, I'll have a link to the files for this. If you happen to be a teacher, you want to print out your own learning cards. I'll also put a link to the full lesson on this. So then that way, if you have any questions or you want to see something more in depth, we can do that. So I'm going to show you the three traditional ways that you show your answers here. Graphically is here, and we're going to do this. We want a number that's larger than 2 and less than -5. Graph how your teacher tells you to do. However, I will usually tell my students, at least in this unit, because at this point, their math is relatively strong. I'm going to just say, as long as it's relatively close to what the scale should be, you don't need to write down all the little separate tick marks. Okay? I want numbers that are larger than 2. It's not going to equal 2. I'm going to use a different color just to be safe. So larger than 2. Now again, remember open circle, because that's going to go through, and that means that it's larger than 2. 2 is not including that. And then it says less than or equal to -5. So at -5, it's going to be a filled in dot, and I want to be less than that. And I'm going to go that direction. Okay, so there's my graph. For the inequality notation, you're going to say two different things. I want x is less than -5, which would be less than or equal to -5, or x is greater than 2. You need the or in there because you can't be in both places at once. You can either be a number that's less than -5, or you can be a number bigger than 2, but you can't be both. Right? For interval notation, the thing which I like about interval notation is it's a lot like your graph. This is going to go down to -infinity. And so the soft bracket, the regular parenthesis, means that you don't actually touch that. We don't touch infinity because it's a concept and not a number. And then I'm going to go up to -5. I'm going to include that, so that's why it's that hard bracket. Union, which is another word for or in probability, but this is what's used in interval notation. And then I'm going to go from 2 to infinity. And again, if the number's not being chosen, I'm going to use that parenthesis there, which means that you go up to, but you don't actually touch the 2. All right, so with that in the back of our back pockets, let's do a couple. Let's start with the quadratic inequality. Again, like everything else, as we get more complicated, you are going to need to check your answers as we go. All right, so in terms of this, you're going to solve it like you normally would if this was an equal sign. So now you're going to solve this as this was a traditional quadratic, like with an equal sign. So same idea. Get everything on one side. Factor it. So I'm going to have a 2x and an x as my front numbers. Question is, where does the 1 and the 3 go? If I do 1 here and 3 here, I'm going to get 6 here and 1 here. So that's going to work. So this will become where the -3 goes. This is going to become a +1. So then when I do the math, again, remember I got 1x here, -6x here. That's how I get my -5. Now, depending upon how you see this, and we're going to graph and write these answers. We're going to do all the answers all three different ways. So from here, I know that this is going to give me x. One of the boundary points is going to be x equals -1/2. This is going to give me a boundary point of 3. So if this is 0, -1/2, put 3 up there. Now the question is, where do I shade? Well, first of all, I'm going to do open circles because I don't have an equality on my inequality. So I'm going to have an open circle there, open circle there. Now again, two different ways. Now remember, parabola is the graph of a quadratic. So if I graph this, I would have this coming through here. I know it's facing up because my leading coefficient up here is positive. So if I'm looking for where is this parabola less than 0, it is going to be in this section right here. So when we do it, it should be shading in between these 2 points. Now to verify that, or if your teacher requires you to do this, or sometimes I'll just have students do this, particularly with rationals, it's helpful. You can test points in each of the different sections. So if x equals 3, or x equals 0, it could be 0, 1, 2, anywhere between -1/2 and 3. I'm going to get 2 times, I'm just going to plug 0 into the equation. So then I'm going to, is 2 times 0 squared minus 5 times 0 less than 3. This turns out to become 0. That's less than 3. So we're good. So that means that 3 is going to be the one. And then you could, if needed, test the other sections as well. I'm not going to do that just for sake of time right now. In terms of other answers, since I'm going in between here, my inequality is going to run from a -1/2. So -1/2 is less than x, which is going to be less than 3. And in terms of my set notation, it will look like that. And that does look like a fair amount like an ordered pair. You just have to, again, it's going to be the context of the problem that's going to be helpful for that one. So now for rationals, let's take a look at that. Rational graphs, we haven't gone through yet. What I will tell you is this. A rational graph tends to, you're going to have an asymptote that goes down the middle, and then you're going to see something that looks like this and something that looks like this. And so you're going to have part that is generally looking negative, and it's going to jump immediately into something that's looking positive. So that's going to have to have in the back of your head in terms of how this is going to work out. However, here we know that 2x plus 1 can't equal 0. So that can equal -1/2. Now, one of the things that I would do is my students will tend to miss this. So I will kind of draw this as I go. Now, the hard part about this is that I would do this in pencil because you don't know if the other answer is going to be less than -1/2 or higher. So I'm just going to kind of just do this lightly, and then I can move that later. So another reason to use pencil, people. From there, I'm just going to go through and solve this. I'm going to find a common denominator, or in this case, I can cross multiply. So I'm going to get 9x because it's just a proportion. Now, the problem with some of this is that, again, depending upon where you are, we don't know if what we're multiplying here is positive or negative. So again, we're going to find a border here, pretty much. So a transition point, and then we'll have to test to see where things go. 9x minus 5. And then when we do all of this, I'll get 5x over here. I get -12 over here. So that's going to be 2 2/5. All right. So coming back up here, so about -2.4. So then I can put the 0 here. Since it says equals, this one it's okay if it equals 0, so I'm going to include that. Now, according to this, it would look like x is less than this. That means we might be going less than this. We'll have to see. 0, again, is always a good point to test. So if I plug in the 0 is, so 9 times 0 is 0, minus 5, 2 times 0 is 0, plus 1 is a -1, -5 over 1, greater than or equal to 7. That's a no, so I'm not going to be in that section there. 2.4, let's pick a number, I don't know, let's just say -1. So then if I do that, I'm going to get -9 minus 5 over -2 plus 1. Is that bigger than 7? Sure enough, that equals 14. So we are going to be bigger. So we're going to be right there in that spot. Okay, so that would be one of those cases that when we did the multiplying, this right here, relying just on what's going on here, when we did the math, we ended up doing something that we're essentially divided by a negative number, and the inequality should have flipped around. And go from there. And again, if I do the negatives again over here for negative 10, let's say, if I do negative 10, I'm going to get negative 90 minus 5 over negative 19. And what you'll see here is while these are both going to be turned positive, it's not going to be bigger than 7. So you have that. So we're going to have all the numbers from negative 2.4 up into negative 1/2. So your other solutions then are going to be, have it because that's what we usually do. I'm going to run from negative 2.4 less than or equal to x, which is less than negative 1/2. And again, if you need help with any of these, the other thing to do in addition to watching the inequality lesson is you could always go back and look for solving rationals, solving absolute value, solving quadratics. All of those are good. Last one, absolute value inequalities. The thing to remember here when we're solving these is that the question is, typically we would write this, we would have 8x minus 5 is equal to 9, and we would have 8x minus 5 is equal to negative 9, and you solve both of those. With the inequality, remember, absolute values talks about distance from 0. So what this is going on, I have this number line, and if this is 0, 8x minus 5 is falling somewhere between 9 and negative 9, because that's what the definition of this is. So since it's falling between those two, I can write this as a compound inequality. So I have negative 9 is less than 8x minus 5 less than 9. If it was greater than, then I would have to break it up into the two bigger ones, because we're talking about being on the outside of those numbers, and you can't be in both places. The nice thing about the compounds is that you can do all of it all at once. So I end up with a negative 1/2 is less than x, which is less than 1 3/4. So again, then I would run an interval notation negative 1/2 up to, you could say 7/4, you could say 1 3/4. I generally don't use mixed numbers. I do here just because it's easier to graph them. So again, defer to what your teacher is telling you to do. So that'd be about 1, about 2, so I'm going to say right there. Now this one's a little bit easier because since I'm saying it's obviously x is between these things, so I'm going to go through there. All right. So again, it's one of those things where you know all the steps. You've done both parts. We're just bringing them together. So hopefully you find that helpful. Like, comment, subscribe, take a look down below, and all that other good stuff you do with all your favorite YouTubers. And with that being said, we'll talk to you later.